Here's an example to illustrate how to use the Excel to solve the binomial probability distribution problems. So let's say we have this problem right here. If a seed is planted, it has 85% chance of growing into a healthy plant. If 10 seeds are planted, what is the probability that exactly 2 don't grow? So now let's extract some information from this question. I know that P, the chances of success, which is growing a healthy plant, is 0.85. And I know that N is equal to 10. And X that I'm looking for is 2. And it is exactly, so X is equal to 2. So I'm looking for the probability that X is equal to 2. The question says here, what is the probability that exactly 2 do not grow? So what is the probability that the plant do not grow? The probability for the plant not to grow is 1 minus 85% or 1 minus 0.85. So I put my information right here. I'm going to pull my Excel chart, and this is P. Sorry, this is P. And this is 1 minus P, which is the probability of failure, and this is the number of trials. Now I'm looking for P, the probability of X is equal to 2, exactly 2. How do I do that? So to find the probability of exactly the number, I am going to use the binomial distribution. So that is the first one. It is going to ask me about numbers, so that is number 2. Comma, and then trials. I know the number of trials is 10. And then the probability. Now, this is the probability of 2 do not grow. So I'm not going to use the probability of them growing. I'm going to use the probability of them not growing, which is 0.15. And then the last one is, do you want cumulative or not? Of course, this is not cumulative since I'm calculating the probability of only one variable, which is X is equal to 2. So I'm going to pick false and then click enter. Now that is the answer that I'm going to get. I will copy this and go back to my homework set and paste it and submit and check the answer correct. Let me try a different example. So I'm going to go to question number 3. The question says a manufacturer machine has a 1% defect rate. If 4 items are chosen at random, what is the probability that at least one will have a defect? So now I see that the probability of having a defect is 0.01 or 1%. N is equal to 4. And I am trying to calculate the probability that at least one will have a defect. So let me go back to Excel and explain that to you. Now, I want to calculate the probability of X is greater than or equal to 1. That is more than at least one item is defect. And going back to the question, I have the number of trials, which is 4. So N is equal to 4. I know that N is equal to 4. So N is equal to 4. So X will have the probability of having either 0 or 1 or 2 or 3 or 4. And I want to find the probability that more than or at least one have a defect. That is, either 1 has a defect, or 2 has a defect, or 3 has a defect, or 4 has a defect. That is the probability of 1 or 2 or 3 or 4. So basically this is the probability of 1 has a defect or X is equal to 1 plus the probability of 2 has a defect, X is equal to 2, plus the probability of 3 plus the probability of 4. Instead of doing all of this and finding the probability of each one of these, which is I can do, I am going to make it simple and I say, I know if I add all of my probabilities up, the answer is going to be 1. So to eliminate only the 0, I can say 1 minus all of these probabilities here added up is equivalent to saying P of X is greater than or equal to 1. That is equivalent to adding all of 1, 2, 3, 4 probabilities up. So you would say 1 minus the probability of X is equal to 0 will answer this type of question. So let me do that. To answer this example, I want to find the probability that X is greater than or equal to 1. So that is equivalent to saying, and so the probability of at least one will have a defect is equivalent to saying 1 minus the binomial distribution of the numbers before 1, all of the numbers before 1. So that is 0. That is the number before 1, and the trials is 4. And the probability is 0.01, and that is a cumulative since there is an inequality here. So let me copy this number and let me go ahead and paste it to my question, and I will get the right answer. Now, I'm going to do it in a different way to show you the long way of doing it. So let's say I'm going to do it the long way. So I have to build a table for X and P of X. Possibilities for X are, since I have 4 trials, are 0, 1, 2, 3, 4. And then to calculate the probability for each one individually, I'm going to use the binomial false. So binomial distribution. And then the numbers, I'm going to click on the first cell to do that automatically, the rest of them automatically for me. And trials is 4, and the probability is 0.01. And this is not cumulative since I'm just calculating the probability for each individual number. And then I populate my table. So what I said before, I said the probability of at least 1, meaning either 1 or 2 or 3 or 4. So this is equivalent to saying the probability for at least 1 defective is adding all of the probabilities up except for the 0, 1. So let me do that. So this is equal to the sum of the probability of 1, 2, 3, and 4 together, and then click enter. And sure enough, I will get the same number. So this is how you're going to do the probability of at least 1 is defective for that specific example. I'm going to do another example to illustrate better. So let's read this example. A company prices its tornado insurance using the following assumptions. In any calendar year, there can be at most 1 tornado. In any calendar year, the probability of a tornado is 0.02. The number of tornadoes in any calendar year is independent of the numbers of tornadoes in any other calendar year. Using the company's assumptions, calculate the probability that there are fewer than 2 tornadoes in a 12-year period. So from this question, I can understand that my probability of success or getting a tornado is 0.02, and the number X is 2, N is equal to 12. And what I'm trying to find is the probability that there are fewer than 2 tornadoes in a 12-year period. So let me put my information here. So my P was 0.02, and the probability of failure, I'm going to calculate that automatically because I've done the formula here. And then the number of trials is 12. So what I am going to calculate is the probability that X is less than 2, that is fewer than 2 tornadoes per year. To calculate that, what I want to calculate is P of X is less than 2. To calculate that, let's see the possibilities of X. The possibilities of X is from 0 to 12. So assume that we're working on the same table here. The last value will be 12 right here. Not going to write the rest of them. I will let that to your imagination. Now I want to calculate all of the probabilities that are less than 2. That means that is 1 and 0. How do I that using the cumulative binomial distribution function? To do that, I am going to click on this cell and say I'm going to do binomial distribution. And now, since this is less than 2, that means I want to include 1 and 0. So I start from 1 because it goes from 1 and then it goes backwards 0 and etc. If we did that 3, that will calculate 2, 1, and 0 and add them together. And the number of trials is 12, and the probability is 0.02. And it is cumulative since I wanted it to add the previous probabilities, that is 1 and 0. So click enter, and that is the number. I'm going to copy this number and go to my homework and paste it, and then submit my answer. And sure enough, I have the right answer. I'm going to do another example. So let's go to number 11 and do that. A high school baseball player has a 0.288 batting average. In one game, he gets 8 at bats. What is the probability he will get at least 3 hits in the game? So that is similar to question number 3 that we answered, if I remember correctly. So let's answer this question. So what is the probability? The probability is 0.288. That means the probability of failure is going to be 1 minus that. I calculated that automatically. And he gets 8 at bat. And we want to calculate what is the probability of him getting at least 3 hits in the game. At least 3 hits means X is going to be greater than or equal to 3. Either you do another table like this one with the probabilities of X are 0, 1, 2, 3, 4, 5, 6, 7, 8, since we have 8 here and is equal to 8. And then find the probability of X in the next column, which is using the binomial distribution. And then the numbers is here, comma, the trials are 8 and the probability is 0.288, and this is not cumulative because we're calculating for each one individually. And then, oh, I see why I did that wrong. Okay. So we said first numbers, the numbers are 0 and the probability is 8, and then populate the rest of the table. So we have all of our probabilities here. So all of the x's that are greater than or equal to 3 is adding the 3 to 8 together. So that is equal to the sum of from 3 to 8 and getting this answer. Now let's try the other approach, which says p of x is greater than or equal to 3 is equivalent to saying 1 minus the binomial of, now which numbers we want to add together? We want to add together 3, 4, 5, 6, 7, 8, but the binomial does not work like this. It works backwards. So if I put 3, it's going to add all of the previous probabilities up. It's not going to add the next probabilities. It works backwards. So for example, if I put 4 here, it's going to calculate all of the probabilities from 0 to 4 and add them up and give me the answer. So what is equivalent to saying I want to add all of the probabilities from 3 to 8? That is equivalent to saying I know that if I add all of these up, the answer is going to be 1. Sorry. I know that if I added this column, I will get 1. So I will say this is equivalent to saying 1 minus the probability of 2 and 1 and 0. How do I do that? I take the binomial distribution and I start from 2. So I say the number 2, comma, the trials is 8, and the probability is 0.288, and this is cumulative since I wanted it to add 2 and 1 and 0 and take it away from 1 to give me the rest of them. So I will get the same number. Now let me copy this number to my answer box and see if I got this answer correctly. And the answer is correct. Here is another example to answer this question. So American Airlines flights from Boston to Atlanta are on time 60% of the time. Suppose 12 flights are randomly selected and the number on time flights is recorded. What we want to calculate the probability that exactly 9 flights are on time. We want to calculate the probability that at most 9 flights are on time. We want to calculate the probability that at least 7 flights are on time. So let's do one at a time. I'm going to erase everything in this side and start all over again. Now let me extract some information. I know the probability of success, which is the flight being on time, is 0.6 or 0.60 or 60%. So I'm going to write that down right here, 0.60. The probability of failure is basically 1 minus that. So I'm going to click this. And I know that n will be the 12 flights that were randomly selected, so the number of trials is 12. Now I want to calculate the probability. The first question asked, what is the probability that exactly 9 flights are on time? To calculate that, that is similar to saying P of X is exactly 9, and we know this is calculated using the binomial distribution with false binomial distribution. So the numbers are 9 and the trials are 12, and the probability of success is 0.6, which is arriving on time. So this is success, arriving on time. This is not arriving on time, and we want to calculate the probability of 9 of them arriving on time. That's why we're using the 60% probability. And this is not cumulative, so I'm going to click false and enter, and that is my first number. So I'm going to go and paste it here and submit my answer. Now let's try the next one and the one after that. The next question is, what is the probability that at most 9 flights are on time? So at most is similar to saying the probability of X is less than or equal to 9. This is how we translate at most. All of the x's that are less than or equal to 9, this is how the binomial works. So if you have the options for x, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Then the probability of all of the x's that are less than or equal to 9 is 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. The probability that will be here will be added together. Let me actually do that. So here is x and here is p of x. Let me calculate the p of x for each one of these using the binomial distribution. So the numbers is this right here, and the trials are 12. The probability is 0.6, and this is not cumulative since I want to calculate for each one individually. Now let me populate the rest of my table. So to find this, either we say equals, I'm going to add everything up to 9, which is sum of all of those probabilities up to the probability of 9, since it's included with the equal sign, and then click enter. Or I could do it with just the binomial, which is what the binomial cumulative does. If I choose x to be 7, then it's going to add all of the probabilities from 7 to 0. If I choose x to be 9, it's going to add all of the probabilities from 9 to 0. And that is exactly what I want here. So similar to that, I could say x is less than or equal to 9 is equivalent to saying the binomial distribution of the numbers, which is 9, comma, trials, that is 12, and 0.6, the probability, and then true for cumulative since it has an inequality here. And since it's less than or equal to, I didn't need to subtract that from 1. So you see, I got the same answer right here. So whatever works for you, either building those long probability tables works for you, or just using the shortcuts works for you. Just do whatever works for you. That will be manageable up to 20, I would say. But if n, the number of trials, is more than 20, then you will have trouble applying this concept right here, and you will have to use the shortcuts that we are doing. So I'm going to paste this here and click submit. And I got the right answer. Now the last one, what is the probability that at least seven flights are on time? At least 7 flights are on time is the same as saying the probability of x is greater than or equal to 7. So what is the probability that all x is greater than or equal to 7? That is adding all of these up. So the binomial does not do this directly, it goes backwards. How do we go over this issue? So either you go from the table and say this is the sum of all probabilities from 7 to the last one and click enter, or you could say I'm going to use the shortcut and I'm going to calculate it using the binomial, and that is all of the probabilities added up. So if you add that up, you will end up with 1 eventually. So that is 1, all of these probabilities, minus from the 6 to the 0. So that is what I want to eliminate from the 1 to get this part right here, which is the answer for this question. So 1 minus binom distribution of the numbers is 7, comma, the trials are 12, and the probability is 0.6. And this is cumulative since I have an inequality, and then click enter. Now I should have started from 6. You see, I should have started from 6. So if I start from 6, I will get the same number because x is greater than or equal to 0. That means I want to add these up. If I take 1 and subtract all of these from 1, I will get this part that I'm looking for. So I should have started from 6. If you start from 6, you will get the same number. Let me copy this number and take it to my homework and see if that is going to work. And sure enough, it works for me. So hopefully those examples are going to help you. If you have any questions, please come on Monday and ask me those questions. Monday will be the last day. We're going to work on binomials. So make sure that if you have any questions to ask at that time, I will see you all in class then.